All right, so here we see a starting screen for the program Stellarium. I've turned on the meridian line and the horizon grid. In other words, the altitude and azimuth grid, right? We know that because there are lines running quote unquote horizontally parallel to the horizon. And if we look straight up at our zenith, we have, well, plus 90 degrees altitude. So this grid is the altitude and azimuth, and it will allow us to estimate the altitude of the sun in this video. And so what I want to show you is basically the sun's path throughout the sky for observers on the two tropic lines and the equator on the 4 special days of the year, the 2 solstices and the 2 equinoxes. So we're looking south in some generic field. I should show you that we are indeed on the Tropic of Cancer, right? And if we look down here closely, north 23 and 30 arc minutes. 30 arc minutes is 1/2 of 1 degree. So that's the same as 23.5 degrees. And the longitude does not matter. We're on that latitude. Anywhere on that latitude is fine. So we're facing south. That means if we turn left, we have due east. And if we turn right, we have due west. Okay. So because we're in this virtual observatory, I'm going to do a little trick to help us observe the entire sun's trajectory. And I'm going to zoom out a little bit. Okay. This will give us a bit of a fisheye lens. And then I'm going to look up. Okay, so just remember that zenith point is actually directly above our heads. Okay, so let's turn on the time and date. Okay, so the year, it doesn't matter. It's in the future. March 21st at 5 a.m. Okay, so just before sunrise. We are on the Tropic of Cancer. So on the actual March equinox at sunrise, let's go to 6 a.m. and the sun, is it due east or is it north of east over here or is it south of east? Well, let's go one more hour, 7 a.m. So it turns out that we're actually seeing the sun observing at due east right there. So let's watch its path during the day. In the morning time, there's 12 p.m., noon. It's not at the zenith. This is important. We're at the Tropic of Cancer, right? On the March equinox, right? We're not on the equator, right? So we're not necessarily at or having the sun at the zenith yet. Okay. What is special about being at the Tropic of Cancer is just that the sun rises east. Okay. So let's keep going and notice that it sets pretty close to due west. Okay. And again, it comes around, does basically the same thing. So internalize this path of the sun right there. Okay. Now let's go to June 21st. Come around to sunrise and notice, whoa, look, the sun rises in the east, but it's, well, to the left of east, which is further north. And so now, again, we're still on the Tropic of Cancer. The sun rises and now passes directly across the zenith. When? Well, basically 12 noon. So let's advance one more minute. Excuse me. 12 noon, the sun is smack dab overhead. In the afternoon, the sun sets now further to the north of due west, right? In the northwest. So the sun remains above the horizon for more hours than what it did back in March, a longer time. So let's see that path link again. Rises and spends more time above and sets way above west or to the right of west. See it one more time. It should arc higher than what it did in March. Remember, March it rose due east, came to about this altitude, and set due west. Interesting. So let's go past sunset. Now it's nighttime, and let's go to the September, 21st. There we go. Equinox. Sunrise. Hey, look at that. Back at due east now. And then it rises very similarly to what it did in March. And then it goes down and sets pretty much due west. All right. Now the sun's path is lower or further south than what it was in June. So thus the sun spends less amount of time above the horizon. Okay. Now it's nighttime. Let's go back to the 21st. There we go. And now let's go to December 21st. Look, the sun rises much further south than due east, right? And so thus you might foresee it setting further south of west. And that's exactly what happens. It spends the least amount of hours above the horizon on December 21st, right? And so at noon, on December 21st, the sun is the lowest altitude it'll ever be in the sky. And again, we're still on the Tropic of Cancer. So what has the sun done throughout the year? Well, we've only done 9 months, I assume, but let's see this trajectory one more time. That's a much smaller arc than what it was back in June, right? And so now if we advance back to March again, it rises back up at due east. Okay, so now let's keep it on the meridian at 12 noon, and let's progress through the months, right? Watch what the sun does at noon every month on the 21st. It's moving back and forth, back and forth. Here it's the highest altitude it'll be. In fact, the zenith. When? June 21st. On September 21st, it's going back down. On December, I passed it. It's the lowest it'll be, and now it turns back around and goes back up. Right? Every day it's rising in the east, setting in the west, but it traverses this pattern across the meridian. And so you might remember in the book, this pattern, this figure 8 is known as an analemma. It's a very slight figure 8. And if you look closely, the shape of the figure 8 is not equal, right? It spins, the bottom part is bigger than the top part. And that's due to the fact that Earth's orbit is elliptical, but that's not for this video, right? But this does a good job of showing that effect, the analemma, okay? So now, that was all for observers at the Tropic of Cancer. Let's go to the equator and see what it looks like, okay? So let's move to the equator. Equator, United States, whatever. Same difference. So equator, latitude of 30 is close enough. Okay, close enough. The year doesn't matter. Let's go to just before sunrise, okay? Let's go to March 21st. Can you guess where it'll rise? We're on the equator. Pretty close to due east. And it rises at noon, boom, smack dab on the zenith. Right? March 21st at 12 noon. Okay? And then it sets like normal. When we go to June on the equator, the June solstice, the sun is directly overhead for observers at the Tropic of Cancer, which is in the northern hemisphere. So thus, it'll be Well, that's weird. It's behind us, actually. Well, let's zoom in a little bit. Let's rearrange ourselves such that the zenith is actually directly overhead. And now, if we turn around and face north, there we go. And now we look up, the sun is closer to the north, which should make sense because right now in June, the sun is directly overhead in the northern hemisphere. And so we're facing north. And so the sun appears a little bit closer to the horizon. Okay, so let's face east and actually see what the sun does. To end this video, let's go back to March and 21st. And now let's go around to sunrise. Notice the angle. What's the sky doing actually? Whoa, it's going straight up. Straight up. It's coming around, moving straight up. That's really weird. Now in June, what's it doing again? It's moving basically straight up. In other words, the angle between the sun's path and the horizon is a right angle. Right? And then going back to September 21st, coming around at sunrise, the sun rises in the east again, sets directly in the west. Same thing. Now it's going back to December. Let me move this out of the way because the sun will rise further to the south now. Sunrise further south. And so progressing through the months, the sun will rise at different locations on the horizon. So I hope this video showed you kind of an empirical view of what the sky would look like.